Adult Solutions. Add-on desired.
Hello students, hope you are doing great. I am Chandrakant, a chemistry facilitator. Welcome to Adult Solutions. We have started the foundation classes and we have completed several topics, right? And now this is a language of chemistry. In this lesson we are going to learn all the fundamental aspects like atom, molecule, ion, element, compound, everything, the complete basic information that we are going to learn. Okay, the get ready with pen and paper while we do the questions also. Okay, let's continue with the word element. Element is a pure substance. In the 6th class matter subject that we learned, and now it's a recap. Element is a pure substance which cannot be divided into two different parts. Two different parts not possible. Okay, so that is called an element. Example, hydrogen you take. Do we able to get the hydrogen to break into oxygen and nitrogen? No, correct? So element cannot be divided into two different materials, two different substances. The term element was first used by Robert Boyle in 1661. The latter, a French chemist, Lavoisier, defined element as the basic form of matter that cannot be broken down into a simpler substances by chemical reactions. The smallest particle of an element is an atom. An element contains of the same kind of atoms. Here we have the examples that iron, carbon, sulfur, mercury, oxygen. Okay, element is a pure substance. Okay, therefore out of 118 elements are till today in all the books. Every book will have 114 elements only. Last 6 or 7 years back, 7th period is completely filled, authorized 118 elements, agonism 118 element, which is in the zero group elements in the periodic table. Okay, so out of 118 elements, okay, so 92 elements occur or naturally available, and other 22 elements are artificially prepared, man-made compounds. Okay, after atomic number 92, all elements are man-made compounds. Okay, students, compound is a substance, is a pure substance which is a composition of 2 or more elements in a fixed composition, a fixed ratio. Suppose you take H2O, hydrogen is 2 grams and oxygen 16 grams, carbon dioxide, carbon 12 grams, oxygen 32 grams. It is a fixed proportion. When we break a compound, we get the possible elements with what it is made up of. That is what the compound. Okay. Compounds are formed when 2 or more elements combine chemically in a fixed proportion. The smallest particle of a compound having existency on its own is known as a molecule. Okay, compound is a bulk material. It is made up of molecules, and molecule is a stable unit. H2O is a molecule, CO2 is a molecule. Any molecule you take, entire in the chemistry, molecules together will give the compound. A bulk material is a pure substance. Properties, physical and chemical properties of compound may or may not be similar to their constituents. It's not mandatory that compound should have the same properties as like their elements. H2O will extinguish the fire. Oxygen will support the fire. See the difference. Okay, so the molecule or the compound need not to be having the properties of what it is made up of. Okay, for example, hydrogen is a combustible substance and oxygen supports combustion. However, water, which is a compound of hydrogen and oxygen, neither burns nor supports a combustion. On the other hand, it is used as a fire extinguisher. Okay, the elements' properties are different, and elements together combining to give a compound, that properties are different. Okay, well, now come back to the meaning of an atom. The smallest particle of matter which may or may not have stability. Well, as the smallest part and may or may not have its stability, existency. Majority of the atoms are not stable. Few atoms like helium, neon, argon, krypton, xenon are stable. Zero group elements in the atomic state stable. Rest of all elements in the periodic table, they are not stable because they have much more energy. Yes, so keep in memory that is the nature law. If anything more energetic, that is not stable. Even you, if you are more energetic, you won't keep quiet. Yes. The building blocks of an ant hill are small sand particles. Yes or no? What it is called? A thill. Thill, right? Ant hill is a thill that is made up of sand particles. Also, bricks are building blocks of the building. Similarly, atoms are building blocks of matter. Atom, which is not stable, that is a fundamental particle of the matter. Atoms are indivisible particles that cannot be destroyed or created by any chemical means. Correct. But this word, this is what given by Dalton, one scientist. Modern chemistry starts with John Dalton. According to Dalton philosophy, this is what the statement. Yes, it is correct, but now in the modern days, atom can be destroyable. Atom breaks down to give electron, proton, neutron, very tiny particles than the atom. It doesn't mean that we will say a matter is composite of electron, proton, neutron. No, we will take the smallest particle of the matter as atom. Okay. According to Dalton's atomic theory, all matter is made up of tiny particles called atoms. This would mean that a rod of iron is made up of millions of atoms of iron rod. Is it? Any material you take, that is made up of atoms. And atom is the direct participation for the chemical reactions. If two molecules are combining, if two molecules are colliding together to give a new material, how it is possible? A molecule having the atom, another molecule having atom, they are directly interacting. If molecules are interacting, it means atoms of that constituent molecules are interacting. Okay, so this is what the information about the atoms. Is the smallest and fundamental particle. It has high energy, may or may not have stability. Only the zero group elements are stable in the atomic state. Helium, neon, argon, krypton, these are atoms, right? This is what the helium, neon, argon, helium, neon, argon, krypton, and xenon, radon, these are all zero group elements, correct? So they are stable atoms. Okay, so the size of an atom. Atom size is very small. Atom size are very small. One cannot see with naked eye. With human eye, we cannot see the atom. That much tiny particle it is. Atoms are very small in size They are not visible even under a powerful optical microscope. Even if you take a powerful microscope, we cannot see the atom. The size of an atom is indicated by the radius of the atom called atomic radius. Okay, generally it is expressed in terms of nanometers, okay, and angstroms, picometers, pm, picometers, such as small measurements. Atomic radius means the center of the atom to the last orbit of electron, right? We know very well electrons revolving around the nucleus in a circular path, and the protons and neutrons present at the center that we call nucleus, correct? Yes or no? Yes. Protons and neutrons will build nucleus and electron in its premises. That is an atom. So center to the last orbit, last electron is called radius, atomic radius. Atomic radius is one of the elemental property. What is that? Is a elemental property. Well, so this is a nanometer. 1 nanometer equal to 10 power minus 9 meters, and 1 angstrom equal to just a small degree, like we write 1 angstrom equal to 10 power minus 10 meters. 1 picometers, spell it once, 1 picometers, PICO, 10 power minus 12 meters. What do you mean by 10 power minus 10? 1 by 10 power 10 in mathematics that you came across the expressions, right? So hydrogen atom is the smallest of all atoms. It's a very small in size. Okay. Well, this is what the size of atom information and its units, the fundamental units. Very simple. You know very well about the centimeter and meters, kilometers. Okay, and you know very well the scale that you are using, that is also having a unit. What is that in your scale? The smallest unit, 1 millimeter, 1 mm, correct? 10 millimeters is equal to 1 centimeter. Yes or no? In your scale 0 to 1, that is 1 centimeter. In 1 centimeter, how many small lines will be there? 10 small lines. Okay, can you try to see that once now? It is very small. 1 mm itself we feel difficult to see. Okay, in that further very small. Okay, one cannot imagine such a small space of atom. Well, in that small space, the total science hidden in it, you know. Here, the representation of an atom. In olden days, we have some presentation, this kind of presentation of an atom. This is old notation. Don't worry, these are not disturbing your IIT and Neet preparation. Okay, because in the modern days, gold we are writing AU, aurum, okay, silver, Ag, lead, a plumbum, mercury, hydrogenum, Hg, phosphorus, P, sulfur, S, oxygen, O, okay, and hydrogen, H, carbon, C. If you want to write water molecule, H2O. Right, this is what the modern notation. This is in olden days, Berzelius, before Dalton. This is what the information. Right, this is what the Berzelius concept. Dalton was the first scientist to use symbols to represent in different elements. Dalton has initiated. After that, different people they given their different attempt. But of course, the symbolic representation not benefited. Not an easy approach. Then after the people started, Berzelius has done this kind of notation, modern notation. Okay. every symbol he proposed also represented a definite a quantity of the representative element, respective element. The symbols of some common elements are proposed by Dalton are shown here. Dalton suggestion, sulfur, oxygen, hydrogen, see there? Okay, this is just a symbols of elements. We no need to bother about it. Okay, in the IIT Foundation, the symbols no need to focus. Okay, it is very difficult to draw, and in the science language it is very difficult. So alternative methods are proposed by the Berzelius. According to Berzelius, the element name first letter will be the capital and second letter will be the small letter. Every element need not to be taken two letters. If suppose carbon has adopted C, carbon element given with capital C, then what about calcium? Calcium cannot be given with C, so second letter has to be accepted. Ca, second letter must be the small letter, carbon and calcium. What about cobalt? Then C small o, cobalt. What about copper? Cu, copper. Okay, if a second element is matching, then go for the third element also. Fortunately, still now there is no 3 letter element. Okay, out of 118 elements, there is no 3 letter element. Even you take 118, that is agonison, OG, agonison. Okay, so the total elements that we learn with 2 letters or 1 letter. Calcium, do we write Ka? No. You take potassium, do we write PO? No, PO is the polonium. Okay, so capital K. Some of the elements has taken with capital letters and second letter must be the small letter. This is what one approach according to the IUPAC system. And there is another approach to take, that is a Latin language. Some Latin words has taken into the giving notation, symbolic representation of the elements. These are all systematic approach. What is IUPAC? It is a international organization whose head body is at Geneva. Okay, so it is an chemistry technical body, international union of a pure and applied chemistry. Pure and applied chemistry. Right now we are learning pure sciences. Applied sciences, when you become a great, then we will apply chemical engineering or something else, that we will prepare some materials for the mankind, right? You will prepare some devices. That is applied chemistry. Okay, so let us see a few elements now. See the symbols of these elements. The modern symbols of some common elements are given in the following table. That is aluminium, Al, aluminium, okay, and argon, Ar, calcium, Ca, carbon, chlorine, Cl, copper, in the Latin language that is cuprum, gold, aurum, hydrogen, iodine, okay, ferrum, plumbum, magnesium, nitrogen, oxygen, kalium, capital K, potassium, that is kalium, silicon, argentinum, natrium, sodium is the natrium, and zinc. Many other elements are there which are accepted in the IUPAC system from the Latin language. Suppose you take W, wolfram, tungsten in English, tungsten, wolfram, SB, stibium, tin, right? SB is the stibium, it is antimony, SN, tin or stannum. Many elements, which elements is accepted into the IUPAC procedure from the Latin language. Okay, The symbolic representation is rather convenient and meaningful. Symbols are significant as they represent a particular element, they represent one atom of that element. Great. They are representing a particular element. Yes, and also they are representing one atom of that element. Nice. Okay, so come to the point of a molecule, which is a stable and least particle. The least particle and stable. Atom is a least particle but not stable. Okay, so the least stable part of matter which can exist, which is existing in the matter, that is called the molecule, whose energy is low. If energy is low, stable. Okay, molecule need not to be a composition of two different elements. It can be same element. Suppose you take H2 is a molecule, O2 is a molecule, sulfur S8 is a molecule, and they are elements. Okay, so we know that the smallest particle of a substance is called an atom. An atom is very small in size and it cannot be divided further. Yes, it cannot be. Although atoms are the smallest particles of substance, atoms of most elements are not stable and cannot exist independently. Therefore, two or more atoms are combining to give a stable unit. Hence, a molecule can be defined as the smallest entity of a substance capable of independent existence. Molecule is capable to independent existence. Okay, the constituting atoms of a molecule are held together by a strong forces. For example, H2 molecule is a molecule in which two hydrogen atoms are chemically bonded. Similarly, hydrogen atoms can also combine with oxygen atom to form water molecule. Yes, a molecule is the smallest particle of an element or a compound that can exist independently and possess all the properties of a substance to which it belongs to. Correct? Take a bulk of H2O. The bulk H2O properties present in the one single H2O. Single molecule H2O compound is a molecule. If that is in the bulk, that is a compound. Compound properties are in the microscopic level the same properties with H2O. Correct? So the molecule can be an element, molecule can be a compound. Okay, it can be made up of different elements or it can be made up of same elements. It is a stable, having independent existence. Independent existence. Do you have independent existence? No, you don't have independent existence. You are dependent on parents and teachers. We guide you, right? Well, not a physical independent existence, right? I'm saying just meaning the existence, right? Independent and dependent. Molecule is an independent and it is stable.
Add-on solutions. Add-on design.